Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of powers, specifically what happens when we divide them, and we'll do it in 5 minutes or less. So we have an expression here, and we've got a lot of exponents here. And so one thing we need to keep in mind, if we look at our mathematics chart or reference materials, when we look at the properties of powers, we're going to see something that looks like this. AM over a to the n, and that's going to equal a to the, then it's going to kind of get a little bit strange here. We're going to end up subtracting those two powers. So what that means is if we have a to a certain power, right? So let's just say, we're going to say 2 squared, okay? Now we have to have the same base. You notice that both of those a's are the same. Those are called the bases, and they both have to be the same, okay, in order for this to work. So those are the bases, and then these right here are the powers, or the exponents. So if the powers are the same, or the bases are the same, actually, that's what we need here. So let's say 2 squared over, let's say, 2 to the first. Well, we've got the same base. So what that means is I can take that base, then I could subtract both of those, right? So that'd be 2 minus 1, which is just 2 to the 1, which is just 2. And we know that this is just 4 over 2, which equals 2. So that's how you can subtract. So what we need to do over here is we need to be looking for, and they're all kind of lined up for us here, similar bases, okay? So we can do 21 divided by 3. Okay, we can go ahead and just put that right there. But now we need this times x, and it's going to end up being 5 minus 3. Now I got similar bases right here. I've got a y, 3 minus, there's not an exponent there or a power there, so we can always assume a 1. 3 minus 1. Then I've got a z, looks big, but look, it's just a 7 minus 6. So what does that simplify to? Well, let's see, 21 over 3 just makes 7. And then I've got an x here of 5 minus 3, so it's just going to end up being x squared. Y is going to be 3 minus 1, so that's also squared. And then z is 7 minus 6, that's to the 1 power. We typically just leave it off. So that's what all of that means. Now, how do we know that really works? Well, let's substitute it here, right? So let's say, all right, let's say that x equals 1, y equals 2, and z equals 3, right? Let's see what all this turns out being. So I'm going to say 21 times, and then x is going to be 1 to the 5th, y is going to be 2 to the 3rd, and then z is going to be 3 to the 7th, over 3, x to the 3rd, so that's 1 to the 3rd. That's 2, just 2 to the 1st, right? And then I've got my z, I've got my 3 to the 6th, okay? So that's all of that with some substitution. All of that should equal what I just did right here. 7, which is, and then x is 1 to the 2nd, y is 2 to the 2nd, times 3. So if those two equal, we're good to go. Obviously, we're going to need to open up our calculator, so let's see what that looks like. So if I simplify this top portion right here, it's 21 to the 1 power, 2 to the 3rd is 8, 3 to the 7th is big, it's 2187. And my bottom, my denominator here, is 3 times 1 times 2 to the 1 power is 2, and then I've got this 729, that's 3 to the 6th power. So those are big. So it simplifies to this. 367,416 is my numerator, 4,374 is my denominator. If I divide that, guess what it equals? 84. Okay, so all of that just makes 84. That's supposed to equal this, right? Because this was a simplified version. Well, what is that? That's 7 times 1 times 2 squared is 4 times 3. Well, 7 times 1 is 7. 3 times 4 is 12. Look at that. 7 times 12, that makes 84. And that's how we divide powers.